objectives. After the completion of this module, you will thoroughly understand the following. What are continuous contour trenches? How do farmers benefit from continuous contour trenches? Suitable location for continuous contour trenches. Tools and implements required for constructing continuous contour trenches. Main parts and operating method of continuous contour trenches. Method of marking and process of construction for continuous contour trenches. Method of constructing continuous contour trenches. Precautionary measures to be taken for continuous contour trenches. Introduction. Today, our state is facing scarcity of rains. Also, failing to initiate methods to conserve rainwater is causing shortage of water in many places. To save our environment and our future generations from such situation, growing of plants and trees is a must. Importantly, growing trees on hillock areas helps cool the water in the clouds, which in turn helps in more rains. This is why growing trees at hilly places is very important. Moreover, the runoff water would take away the upper layer of fertile soil along with it. Formation of upper layer of 1 inch of rich and fertile soil would require hundreds of years. Hence, protecting such fertile soil is very much needed. More of rainwater from hillock areas goes waste. By conserving the rainwater, we not only increase the percentage of soil moisture, but also create a suitable environment for growing plants. So, the continuous contour trenches of Mahatma Gandhi National Rural Employment Guarantee Scheme is all about avoiding soil erosion and increasing the fertile land, increasing the soil moisture, creating a suitable atmosphere for growing trees, which helps in protecting our environment. By digging across in water catchment areas of barren hill slopes and alongside of contour, connecting the lines is called the continuous contour trenches. These continuous contour trenches are dug on a predetermined top width and bottom width with measured depth. A berm is left under the trench and an earthen bund is constructed with predetermined top width and bottom width. Benefits of continuous contour trenches. Now let us know the benefits of continuous contour trenches. By digging continuous contour trenches, the speed of runoff water that flows from hills can be stopped to a certain extent. By digging continuous contour trenches, the soil erosion is minimized. At the same time, the rich and fertile soil is protected. The absorption of rainwater in these trenches helps increase in soil moisture and underground water resources. A suitable environment for growing trees is created because of increase in soil moisture. Suitable location for constructing continuous contour trenches. Now let us see where continuous contour trenches are constructed. Continuous contour trenches are constructed on barren hills with slopes of 6 to 20% and across the slope. Continuous contour trenches are constructed across the slope in places where rainfall is less. Continuous contour trenches are constructed on hills where rocks and trees are not hindrances on contour lines. Tools and implements required for constructing continuous contour trenches. Implements: thread, lime powder, tape, wooden sticks, hydro marker. Tools: crowbars, spades, cane baskets, rammers, wooden mace. Main parts and operating method of continuous contour trenches. Now let us know how the main parts and operating method of continuous contour trenches. In continuous contour trenches, 0.9 meters top width, 0.3 meters bottom width, 0.5 meters depth. Berm with 0.6 meters length. Earthen bund of 1.7 meters bottom width, 0.3 meters top width, 0.5 meters height. One solid portion for every 5 or 10 meters in every trench. A surplus weir to prevent any damage to earthen bunds. Stone pitching in places where trenches meet with short curves. Operating method: the runoff water from the hills reaches to trenches that are constructed across the slope. Water absorption at these trenches would help increase the soil moisture. The berm under the trench prevents the soil from reaching trenches. The earthen bunds not only prevent the speed of the runoff water but also help in stopping the water in its place. Method of marking and process of construction for continuous contour trenches. Method of marking and process of construction for continuous contour trenches. Before marking the place for constructing the continuous contour trenches, the distance between trenches must be established. See the below chart for determining the distance between the trenches. Percentage of slope up to 10%. Distance between trenches 5 meters. Length of trench per acre 750 meters. Percentage of slope up to 10 to 15%. Distance between trenches 3 to 5 meters. Length of trench per acre 1325 to 750 meters. Method of marking and process of construction for continuous contour trenches. When marking to construct the continuous contour trenches, the contour lines must be marked. Method of marking contour lines. If the slope has 10% as per the chart, distance between the trenches must be 5 meters. So, a contour line is to be marked from the top area of the hill. Fix a wooden pole at 5 meters distance from the top. Hydromark at one side as X1. Pull the second edge 5 meters along with the line to be marked. Interchanging this second edge when the spirit level in the hydromarker is equivalent, fix a wooden pole and mark it as X2. Now keep the hydromarker at X2 and pull the second edge alongside of the line, interchanging it. When the spirit level in the two edges is equivalent, fix a wooden pole and mark it as X3. This way, fix wooden poles around the hill using the hydromarker. Join the wooden poles with a thread and mark them with lime powder. Let's call this line 1. 5 meters from this contour line 1, mark another contour line with aforesaid method. The contour lines are marked this way as shown on the screen. Now, marking should be wider on the trench from contour line 1. Method of marking. With the help of tape along the contour line 1 from X1 to 0.15 meters away and fix a wooden pole and mark this point as A1. From X1, measure 0.15 meters on upper side and fix a wooden pole and mark it as B1. Join A1, X1 and B1 with a thread. Draw a line with lime powder along the thread which tied A1, X1 and B1. From X2, measure 0.15 meters on bottom side and fix a wooden pole and mark it as A2. From X2, measure 0.15 meters on left side and fix a wooden pole and mark it as B2. Join A2, X2 and B2 with a thread. Draw a line along the thread which tied A2, X2 and B2 using lime powder. From X3, measure 0.15 meters on bottom side and fix a wooden pole and mark it as A3. From X3, measure 0.15 meters on upper side and fix a wooden pole and mark it as B3. Join A3, X3 and B3 with a thread. Draw a line along the thread which tied A3, X3 and B3 using lime powder. From X4, measure 0.15 meters on bottom side and fix a wooden pole and mark it as A4. From X4, measure 0.15 meters on upper side and fix a wooden pole and mark it as B4. Join A4, X4 and B4 with a thread. Draw a line along the thread which tied A4, X4 and B4 using lime powder. Join A1, A2, A3 and A4 with a thread. Join B1, B2, B3 and B4 with a thread. Draw a line along the thread which tied A1, A2, A3, A4 using lime powder. Draw a line along the thread which tied B1, B2, B3, B4 using lime powder. The distance between A1, A2, A3, A4 and B1, B2, B3, B4 indicates the bottom width of the trench. Marking the bottom width of the trench. From A1, measure 0.3 meters on bottom side and fix a wooden pole and mark it as P1. From B1, measure 0.3 meters on upper side and fix a wooden pole and mark it as Q1. From A2, measure 0.3 meters on bottom side and fix a wooden pole and mark it as P2. From B2, measure 0.3 meters on upper side and fix a wooden pole and mark it as Q2. From A3, measure 0.3 meters on bottom side and fix a wooden pole and mark it as P3. From B3, measure 0.3 meters on upper side and fix a wooden pole and mark it as Q3. From A4, measure 0.3 meters on bottom side and fix a wooden pole and mark it as P4. From B4, measure 0.3 meters on upper side and fix a wooden pole and mark it as Q4. Join A1, P1 wooden poles with a thread. Join B1 and Q1 wooden poles with a thread. Join A4 and P4 wooden poles with a thread. Join B4 and Q4 wooden poles with a thread. Join P1, P2, P3 and P4 wooden poles with a thread. Join Q1, Q2, Q3 and Q4 wooden poles with a thread. Draw a line along the thread which tied A1 and P1 using lime powder. Draw a line along the thread which tied B1 and Q1 using lime powder. Draw a line along the thread which tied A4 and P4 using lime powder. Draw a line along the thread which tied B4 and Q4 using lime powder. Draw a line along the thread which tied P1, P2, P3 and P4 using lime powder. Draw a line along the thread which tied Q1, Q2, Q3 and Q4 using lime powder. The distance of 0.9 meters between P1, P2, P3, P4 and Q1, Q2, Q3, Q4 indicates the upper width of the trench. Continue this way around the hill. Marking the berm line. From P1, measure 0.6 meters on bottom side and fix a wooden pole and mark it as S1. From P2, measure 0.6 meters on bottom side and fix a wooden pole and mark it as S2. From P3, measure 0.6 meters on bottom side and fix a wooden pole and mark it as S3. From P4, measure 0.6 meters on bottom side and fix a wooden pole and mark it as S4. Join S1, S2, S3 and S4 wooden poles with a thread. Draw a line along the thread which tied S1, S2, S3 and S4 using lime powder. The distance between P1, P2, P3, P4 and S1, S2, S3, S4 indicates width of 0.6 meters of the berm. Method of marking for earthen bunds. From S1, measure 0.9 meters and fix a wooden pole and mark it as T1. From S2, measure 0.9 meters and fix a wooden pole and mark it as T2. From S3, measure 0.9 meters and fix a wooden pole and mark it as T3. From S4, measure 0.9 meters and fix a wooden pole and mark it as T4. Join T1, T2, T3 and T4 wooden poles with a thread. Draw a line along the thread which tied T1, T2, T3 and T4 using lime powder. Join S1 and T1 with a thread. Join S2 and T2 with a thread. Join S3 and T3 with a thread. Join S4 and T4 with a thread. Draw a line along the thread which tied S1 and T1 using lime powder. Draw a line along the thread which tied S2 and T2 using lime powder. Draw a line along the thread which tied S3 and T3 using lime powder. Draw a line along the thread which tied S4 and T4 using lime powder. The distance between S1, S2, S3, S4 and T1, T2, T3, T4 indicates bottom width of earthen bunds. The marking should continue around the hill. With the help of tape along the contour line from S2, S3 and S4 to 3 meters, fix a wooden pole and mark this point as C1. With the help of tape along the contour line from T2, T3, T4 to 3 meters, fix a wooden pole and mark this point as C2. Join C1 and C2 with a thread. Draw a line along the thread which tied C1 and C2 using lime powder. The distance between S2, C1, C2 and T2 indicates the area of surplus wear. Method of constructing continuous contour trenches. Excavate 0.5 meters depth on all four sides in the bottom portion of the trench, that is A1, B1, B4 and A4. The excavated soil is to be kept beyond the berm and in the center portion of A1, T1, T4 and S4. When placing the excavated soil in the center portion of S1, T1, T4 and S4, soil to be kept at a thickness of 9 inches or 23 centimeters in a row. Dig the middle area of A1, B1, B4 and A4 for getting an even 0.5 meters on all four sides. Solid portions of 0.030 for every 10 meters are to be left out while digging in the center portion of A1, B1, B4, A4. Dig upper width in the center of P1, Q1, Q4 and P4. Dig the slopes of the trench in such a way it connects both the lines of P1, P2, P3, P4 and A1, A2, A3 and A4. Dig the slopes of the trench in such a way that it connects both the lines of Q1, Q2, Q3, Q4 and B1, B2, B3, B4. When digging the slopes, dig the remaining portions of the left out solid portions of 0.3 meters. Trim with a crowbar for getting an even and orderly slope on all the four sides. Construction of earthen bund. Now let us know, as part of constructing continuous contour trenches, how earthen bund is constructed at the bottom of the trench and beyond the berm. As mentioned earlier, the excavated soil was deposited at a thickness of 9 inches or 23 centimeters in the center portion of S1, T1, T4 and S4. Sprinkle the water on the excavated soil and make the lines firm with a wooden rammer. Break the solid blocks of earthen material with a mace. The earthen bund is to be increased 23 centimeters height with strengthening, constructing the height of the bund to 0.5 meters. The earthen bund must be constructed so as the upper width of the bund would be 0.3 meters, concurrently strengthening the slope. This process must continue around the hillock. During the construction of trenches, surplus weirs must be constructed where water flow is intense. The constructed continuous contour trenches are as shown on the screen.
మట్టికట్ట నిర్మించేటప్పుడు కొండవాలు ప్రాంతంలో నీటి ప్రవాహ ఉధృతికి ఏర్పడిన బలమైన చారికలు అనుసరించి కొంత భాగాన్ని కట్ట నిర్మించకుండా వదిలివేస్తాం. ఈ భాగంలో ప్రవాహ ఉధృతికి మట్టికట్ట కూలకుండా అలుగు నిర్మించాలి. అలుగును మార్కింగ్ చేయుటకు ముందుగా మట్టికట్ట మధ్య భాగంలో ఒక లైను గీయాలి. ఈ లైను రెండు చివరలలో ఒక్కో కర్రముక్క పాతాలి. ఈ కర్రముక్కలను C1, C2లుగా గుర్తించాలి. C1, C2లను కలుపుతూ దారం కట్టి ఉంచి సున్నం వేయాలి. C1 నుంచి దిగువ వైపు 0.50 మీటర్ల దూరంలో ఒక కర్రముక్క పాతి దానిని D1గా గుర్తించాలి. C1 నుంచి ఎగువ వైపు 0.50 మీటర్ల దూరంలో ఒక కర్రముక్క పాతి దానిని D2గా గుర్తించాలి. C2 నుంచి ఎగువ వైపు 0.50 మీటర్ల దూరంలో ఒక కర్రముక్క పాతి దానిని D3గా గుర్తించాలి. C2 నుంచి దిగువ వైపు 0.50 మీటర్ల దూరంలో ఒక కర్రముక్క పాతి దానిని D4గా గుర్తించాలి. D1, C1, D2లను కలుపుతూ దారం కట్టి ఉంచాలి. D2, D3లను కలుపుతూ దారం కట్టి ఉంచాలి. D3, C2, D4లను కలుపుతూ దారం కట్టి ఉంచాలి. D4, D1లను కలుపుతూ దారం కట్టి ఉంచాలి. D1, C1, D2లను కలుపుతూ కట్టి ఉంచిన దారంపై సున్నం వేయాలి. D2, D3లను కలుపుతూ కట్టి ఉంచిన దారంపై సున్నం వేయాలి. D3, C2, D4లను కలుపుతూ కట్టి ఉంచిన దారంపై సున్నం వేయాలి. D4, D1లను కలుపుతూ కట్టి ఉంచిన దారంపై సున్నం వేయాలి. C1, C2లను కలుపుతూ కట్టి ఉంచిన దారంపై C1 నుంచి 0.50 మీటర్ల దూరంలో ఎడమవైపు ఒక కర్రముక్కను పాతి దానిని E1 గా గుర్తించాలి. C1, C2లను కలుపుతూ కట్టి ఉంచిన దారంపై C2 నుంచి 0.50 మీటర్ల దూరంలో కుడివైపు ఒక కర్రముక్కను పాతి దానిని E2 గా గుర్తించాలి. E1 నుంచి దిగువ వైపు 0.50 మీటర్ల దూరంలో ఒక కర్రముక్క పాతి దానిని E3 గా గుర్తించాలి. E1 నుంచి ఎగువ వైపు 0.50 మీటర్ల దూరంలో ఒక కర్రముక్క పాతి దానిని E4 గా గుర్తించాలి. అలాగే E2 నుంచి ఎగువ వైపు 0.50 మీటర్ల దూరంలో ఒక కర్రముక్కను పాతి దానిని E5 గా గుర్తించాలి. E2 నుంచి దిగువ వైపు 0.50 మీటర్ల దూరంలో ఒక కర్రముక్క పాతి దానిని E6 గా గుర్తించాలి. E3, E1, E4లను కలుపుతూ దారం కట్టి ఉంచాలి. E5, E2, E6లను కలుపుతూ దారం కట్టి ఉంచాలి. E3, E1, E4లను కలుపుతూ కట్టి ఉంచిన దారంపై సున్నం వేయాలి. E5, E2, E6లను కలుపుతూ కట్టి ఉంచిన దారంపై సున్నం వేయాలి. ఈ మార్కింగ్ స్క్రీన్లో చూపిన విధంగా ఉంటుంది. అలుగు నిర్మించు విధానం చూద్దాం. అలుగు నిర్మించుటకు 9 ఇంచుల లేదా 225 మిల్లీమీటర్ల కంటే ఎక్కువ మందం గల రాళ్లు వాడాలి. ముందుగా D4, E6, E5, D3 మధ్య భాగంలో 0.30 మీటర్ల లోతులో పునాది తవ్వాలి. అలాగే E3, D1, D2, E1 మధ్య భాగంలో కూడా 0.30 మీటర్ల లోతులో పునాది త్రవ్వాలి. ఇలా త్రవ్విన D4, E6, E5, D3, E3, D1, D2, E1 మధ్య భాగంలో 225 మిల్లీమీటర్ల రాళ్లతో పూర్తిగా భూమట్టం వరకు నింపాలి. E3, E4, E5, E6ల మధ్య భాగాన్ని కూడా 0.30 మీటర్ల లోతులో త్రవ్వాలి. ఇలా త్రవ్విన E3, E4, E5, E6ల మధ్య భాగంలో 225 మిల్లీమీటర్ల గల రాళ్లతో భూమట్టం వరకు నింపాలి. ఇప్పుడు ఇరువైపులా ఉన్న మట్టి కట్ట గోడలపై 0.30 మీటర్లు మార్క్ చేసుకుని ఒక దారాన్ని ఈ 2 మార్క్ చేసుకున్న భాగాల నుంచి లాగి ఉంచాలి. ఇలా మార్క్ చేసుకున్న దారం ఎత్తు వరకు E3, E4, E5, E6 మధ్య భాగంలో 225 మిల్లీమీటర్లు రాళ్లు వేస్తూ పారాబోలిక్ లేదా పరావలయ రూపంలో అలుగు నిర్మించాలి. తరువాత ఇరువైపులా ఉన్న మట్టికట్ట వింగ్ వాల్స్ ని కూడా 225 మిల్లీమీటర్ల రాళ్లతో మట్టికట్ట పూర్తి ఎత్తు వరకు నిర్మించాలి. ఈ విధంగా నిర్మించిన అలుగు స్క్రీన్లో చూపిన విధంగా ఉంటుంది.
Precautionary measures to be taken while constructing continuous contour trenches. Trenches must not be excavated if there are stones or trees on the lines of the contour. When continuous contour trenches are being excavated, there must be no stones, trees on the lines of the contour. Continuous contour trenches must not be constructed from lower portion to upper portion on a slope. Continuous contour trenches must always be constructed from upper portion to the lower portion on a slope. Continuous contour trenches must not be constructed on barren hills with greater soil depth. Continuous contour trenches must always be constructed on barren hills with lesser soil depth. Trenches must not be constructed without planting trees. When digging the trenches, plant the trees in the trenches with 3 meters gap between them. Doing so would increase the greenery around the hill. Earthen bunds must not be constructed without leaving the berm. Earthen bunds must be constructed beyond the berm. This berm prevents the soil in the earthen bund from reaching the pit. The soil must not be left out without constructing the earthen bunds with predetermined measurements. The earthen bunds must be constructed with predetermined upper width and bottom width. Trench must not be excavated without constructing surplus weirs where water flow is intense. During the construction of trenches, surplus weirs must be constructed where water flow is intense. This surplus weir will prevent any damage to the walls of trenches due to heavy water flow. Pitching should not be left out where small curvatures meet in trenches. Pitching must be done at small curvatures meeting place in trenches. This will prevent erosion at the bottom place of the trench. Trenches must not be constructed without leaving the solid portions. At every 5 or 10 meters, solid portions of 0.3 meters must be left out. These solid portions would be useful for storing the water, reducing the speed of water flow, and for measurements. Trenches must not be excavated without first marking the contour lines. Trenches must be dug only after marking the contour lines. Trenches must not be excavated without first determining the percentage of the slope. The percentage of the slope must be determined with a hydromarker or a frame. Trenches must not be excavated without first establishing the distance between the contour lines. The distance between the contour lines must be established based on the percentage of the slope.